Today we're going to look at these 3D figures. I'm going to look at surface area and volume. Surface area and volume. So polyhedra. What's that? A polyhedron is a solid whose sides, now we call them sides, we're going to start calling them faces, because when we think of a side, I think of a 2D figure and its side. So we have faces when we talk about polyhedra, and the faces are polygons. So here you can see some polygons making up the faces of this particular polyhedron. It's just a 3D figure with many different faces. That's what that means. An edge is where they meet. So this guy here is an edge, here's an edge, here's an edge. A vertex is where 3 or more edges meet. So it's a point. Here's a vertex. Here's a vertex. Here's a vertex. Where the edges are all meeting. So let's see. On this particular figure, on this polyhedron, how many faces are there? 6. How many edges?
12.
Which is it? I'm hearing all kinds of numbers. 107. How many? Count them. Right, you've got 1, 2, 3, 4 going around. 1, 2, 3, 4 up here, and 1, 2, 3, 4 down here. 12. Now, how about these vertices where they all meet up? 8. Now, so that's what new words. New words. All right. So examples of polyhedra. So we're going to learn about prisms. Prisms are when you take you take 2 polygons that are congruent and you kind of just stretch them apart. So if you had a nice a rectangle shape, you just pulled it up. That is a prism. Here I have a pentagon on the bottom here. If I just pulled it up and stretched it out, now I have a prism with polygon bases. So we have a polygon base. So this would be a pentagonal prism. Is that how you say it? This one is a rectangular prism. Yes. If you have a right prism, yes. So if you, very good, right? So if these form right angles, if this edge forms a right angle, or this face is a right angle with that base, then yes, you're going to have parallel sides all around. But they could be tilty. So you think about, if you have a stack of paper and just kind of push it a little bit, you can have prisms that are tilty as well. But if they're not, they're called right prisms. Absolutely. We have pyramids. So your base of a pyramid, you only have one base, and that's a polygon. So this one looks like a rectangular base. This one has a triangular base. So this is a rectangular pyramid and a triangular pyramid. 1 point on top. And these things are not polyhedra. They're 3D figures, and we're actually going to be looking at all these things. But if you have rounded sides, they're technically not a polyhedra. Because those are polyhedra. Because these have to be polygon bases. Just, some technical points here. Polyhedra. Isn't there some Greek thing? Has many faces, the polyhedra or the hedra thing? I think the hydra, yeah. So I think it comes from the same word. I'm no expert, so I could be wrong. Oh, Euler. Euler had a lot of time as a very famous mathematician, Swiss mathematician. He figured out that if you add up the faces and the vertex, it's the edges plus 2. So if you're trying to figure stuff out, you can use this formula if you so desire, or you can just count them. That's my method. Count around them, but I want to know how many faces and things like that. Good old Euler. Okay, so surface area and lateral area. Surface area. Nets. You might have worked a little bit with nets. It's when you take a polyhedron and you unfold it, and I've got a little website here. This is called the tetrahedron because it has 4 different polygons making it up. So that's its net. Let me put it back in its shape. Yeah. So this is a tetrahedron, but it has a net. It's made up of polygons, and you can unfold these sides. There's somebody get it fly again. So anyway, when you look at surface area, can I reset this now? So this here is a cube, right? There it is, a solid 3D figure. If you unfold it and you find the area of all the polygons that make it up, that is surface area. It's like you gift wrap a box and if you didn't have any overlap, we always use overlap to tape it close. But if you just had it match exactly, that is surface area. Surface area. So we're going to kind of find that stuff. It's the sum of the areas of all the different faces. Lateral area is just the sides. Lateral means side. So it's the sum of the sides without the bases. It's like toilet paper roll's a bad example because it's not a polyhedra, but pretend it was. If you just wanted to wrap the sides, it doesn't have bases, whereas the soup can has the bases. So lateral is without the bases. Just looking at those. So how do you do it? So the surface area of prisms, and this is kind of what you were talking about a little bit, Rachel. This is a right prism, and it looks rectangular. But you can also have what's called an oblique prism. You think about a strong wind, it just kind of blows it over a little bit. Or, leaning tower piece, it just kind of tilts it over there a little bit. It's oblique. The height, you measure straight up and down from the top. So it's easy to see it when you have a right prism. But if you have an oblique, it's the same thing. If you're standing on the edge, you drop a penny. That's your height. That's your height. How do you find surface area? Well, it kind of makes sense. The surface area, the whole thing, is you find the lateral area. So you find the areas of just the sides, and then you add in the base twice, because there are two bases. And that will give you the surface area of the whole thing. And so some of the little abbreviations, LA is for lateral area, can be lateral areas, that surface area is just the sides. Capital B, now this uppercaseness is important. It means it's the area of the base. Remember, our bases can be rectangular, they can be triangles, they can be pentagons, they can be any polygon you want. So we're using capital B just means general area of that base. The height is the distance between the bases. So decide where your bases are, and that's the height. If you kind of turn this one the other way and say, well, I think these are the bases, you can do that, but now your height would be this way. So distance between the bases, that's kind of important. And the small p represents the perimeter of the base. So if this is your base perimeter, it's that sum of the sides all the way around. To unfold a prism, so I'm unfolding looks like a triangular prism here. And I'm just looking at its neck. So let's see, I want the area of this plus the area of that. So I'm calling this area capital B. That's where 2B comes from. Just find the area of those triangles. Now the lateral area, let me go tune in. Some people are so tuned out. Come back in. Come back in and look. Alright? So I have 3 rectangles. I'm calling this length side because it's matching kind of the side of that triangle. This small b is matching this length. And this c is matching the length of that side. But remember, we're just unfolding it. So how do I find this area if this is my height? Well, to find the area of this guy, it's h times a. To find the area of this guy, we'll be able to see it, h times b. And this one is h times c, right? And I add those up, and that's how I get the lateral area. So here I am adding them up. I'm noticing that h is a common factor, so I just took it out. That's what I did in the next little equals here. Now, a plus b plus c, a plus b plus c, is the same as adding a plus b plus c, which is the perimeter of the base. So the lateral area is the same as the height times the perimeter of the base. So we're going to take advantage of that when we look for surface area of prisms. Yeah? So, and you're going to want your formula sheets. Anybody, you got your formula sheets handy? Because I use them too. You might want to take this out and kind of follow along with your formula sheet. Make good friends with this. This one is really helpful because surface area can sometimes be a little tricky. So if you look for the prism, and on the formula sheet they have 2 prisms. They have a triangular prism and a rectangular prism, but you can apply that to other things. So it says here that surface area equals HP plus 2B, because HP is your lateral area. So he said if you add these things up, the areas of those faces plus these 2 guys, and so we need to figure this out. Now please, I want to see this. You turn something in, I want to see what formula did you use. Now what I do, to try and keep it a little bit organized, is I'm going to say, well, let me work on these a piece at a time. Let's see if we can figure out HP, height times perimeter of base. So as hopefully we recall, this is my base here, and it is, these triangles. triangles and stretched them out, made this prism. That's the base, that's capital B when I find that area. This is the height of the prism. Height is the distance between the bases. So there's height. So I know height. They gave it to me. It's 9.1. Now P is perimeter of the base. Now I have these little guys here. So that means this one's 8, 2. It's an isosceles triangle. That question? Yeah. Well, it's like they took my prism and they flipped it over. And how do I know this bottom thing, this rectangle shape is not the base? That's a good question. How do I know this one's not the base? How do I know? It doesn't have a match up top. You want to see these parallel congruent bases. These are always going to be parallel. You want to have these opposite. So you have to kind of picture which polygons got stretched out. When I look at this guy, there's no matching box on top of it. So it is a triangular base here. That's actually an excellent question. So these are the bases. You have to have two matches in a prism. Now let's see, perimeter is what, 19? So I have HP. So HP is going to be 9.1 times 19. 9.1 times 19, what's that? 172.9? Yeah. That's what I got too. Looks like a lot, doesn't it? I guess that makes sense. So we're halfway there. Now we have to find 2B. Well, I know B, again, this represents area of the base. Capital B means area of the base. So 2 times 2B equals 2 times the area of the triangle. What's the area of the triangle? 1/2. Small b times h. And this is, gets confusing because this h is not that h. It's this one. It's like I pulled out of the triangle base, and now I'm working with this. So I'm missing this piece right here. That's what I need to find. But look what I got going here. This thing and this thing are going to cancel out. So twice my base is just going to be b times h. Small b times small h. My little local one's right here. So now I got to figure that out. How am I going to do that? Oh. Well, let's see. I know, what do I know? This thing's 3. So I kind of have small b. How am I going to find this guy? Well, once again, I have an isosceles triangle. So if you drop this height here, what's going to happen to these two pieces? They become congruent in an isosceles triangle. We just proved this a moment ago. Angle, side, congruent. So this is 1.5. Yeah? If I have a right triangle and I know 2 sides, how do I find the third side? Pythagorean theorem. So h, little h here, is going to be the square root of 8 squared minus 1.5 squared. Pythagorean theorem. Why not read calculator? I'd like somebody to do that. Check my work. 7.9? That's what I got too. You're following where this is all coming from? Because you guys are so quiet. We're sleeping. The base is 3, because they told me. The base is 3. I'm working this formula now. It's 3. And now I just found the height by using the square root of 1.5 squared plus height squared equals, the square root. This squared plus that squared is that squared. That is here. And Nathan and I both got 7.9. Anybody else get that? Everybody? Yeah? Okay. So now we have to do 3 times 7.9. What is it? 3.79? 3 times 7.9? Somewhere around 24, right? That was somewhere around 24. 3.6? 7-ish? Somewhere around there. And we're doing a little bit of rounding here. So now I just substitute into my formula. We found HT. We found this guy. Now we add it up. What do we get? What's my units? Oh, what kind of units do we have in surface area? That's a good question. And they're meters. What kind of meters? Square meters. Now, why are they square meters? I'm taking areas and I'm adding them. surface area is area. It's the area of all these faces. So it's going to be square meters just like any other area. So get your units right. And that's it. Now the key to these, they can get confusing pretty quickly. So, you know, try and be as organized as you know how. Yeah.
So what if I
Yes. Right, and if we go back to the picture, why is it just one base? Because it's this times this plus this times this plus that times that. So I take it out, this is just one perimeter. Okay? So it's all because I played with the formula a little bit. So yeah, it is just one of those. Anybody following this? Because these can quickly get confusing. What I don't want to see, I give you a test or something afterhand, is numbers. I mean, this is bad enough. I can sort of follow it. Numbers everywhere. Or even worse, surface area, magic number. Yeah, I need to see where you got it. I want to see this formula. I want to see the substitution. I want to see how you got those values. You're writing me a little math essay for these. All right, cylinders. So cylinders are soup cans. So let's see, what do we have here? It's the lateral area plus twice the base. It's really the same idea, only now they're just not polygon sides. So what do we got? So lateral area plus 2 pi r squared. Because pi r squared, isn't that the area of a circle? And I got 2 of them, so that's where that comes from. And the lateral area. Well, what is the lateral area? It claims to be 2 pi r h. Let's see. All right, I'm unfolding my soup can. Take the label out. Here's the lids. So I think we can see, I hope, pi r squared, that's where the 2 pi r squared is coming from. What about the area of this? Well, h is just how high it is, so that's what's going on here. Well, what's this length? It's the distance around a circle. What's the formula for distance around a circle? 2 pi r. So, it's 2 pi r, right? Is that circumference? 2 pi r? So 2 pi r times h will give me this area, and that's what it comes from. So if you want the surface area of a cylinder, 2 pi r h plus twice the base. What if you just want the label of the soup can? Then just do the 2 pi r h. That's your lateral area. Okay, so it's the same idea. Lateral area plus twice the base. They're really the same thing, but I know more about circles. I've got some different formulas, getting pi involved. So if I want to find the surface area of this cylinder here, and again, this is on the bottom of the page, is it different? Oh, okay, well, this is a different one. All right, well, let's do this one. So, not so hard. What's the formula? SA equals 2 pi RH plus 2 pi r squared. Now, you can work with this, or you can notice, wait a second, I've got some common factors here. 2 pi r. Let's factor that out. What's here? An h and another r. I find this one's a little bit easier to work with when you're trying to fill these guys out. So, what do I have here? R is 6 and h is 4.9. So 2 pi times 6 times 4.9 plus 6. Just put this junk in a calculator. I tend to do pi last. I work with the numbers first. So 2 times 6 times 4.9 plus 6. Hopefully I'm typing that in right, which is 130.8 pi. So if you needed the answer in terms of pi, it would be that. But if I want an estimate, just multiply that number by pi. Yeah, I'm doing it. And it's roughly, approximately 410.92. What are my units here? Again, surface area are square units, square centimeters. So hopefully this is the one I'm going to, yeah, this is the guy in your paper. So let's try it again here. So SA, always write out your formula. 2 pi r times h plus r. I tend to use this one. I think it's easier than the big one. I think this is the one on your formula sheet, right? I don't think they break it down for you. They don't, but you can do that. So let's see, r is 4, h is unknown, and I know the surface area. So when they do this, you just use the formula and plug in what you know to find what you don't know. little bit. 168.09 equals, that's 8 pi, right? Times h plus 4. Solving for h, why don't I divide by 8 pi? And what do I have now? I've got h plus 4 equals 168.09 over 8 pi. H by itself, got to subtract 4 from both sides. So h equals 168.09 times 8 pi minus 4. I have to say this. One thing I noticed about the test was very creative use of formulas. You want to go as far as you can before you touch the calculator. Because here's a problem I noticed on some papers. You were like, okay, let me do this. 168.09, maybe you did it here, 8 pi, and you truncated immediately. You said, okay, I'm going to round that to the nearest 10. And then you took some of these guys and you rounded to the nearest 10. By the time you got here, you were so far off that your rounding was like crazy. It wasn't even close to the right answer. It was like significantly off from the right answer. You don't want to round, unless you really have to, until you get to the very end. So what I would do now is I solve it for h, what I want to find. I haven't done any calculations yet with the calculator. And then I'm going to put it into the calculator as best I can at one go. So this is 168.09 divided by 8 pi. 8 pi. Okay, that whole thing minus 4. And I'm getting 2.23, blah, 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 blah. Now you round. If it doesn't say how to round, round to the nearest hundredth. So what does this become? 2.69. And then what's my unit? These are meters. I'm finding a height. So I'm not squaring it or anything. So how tall is that thing? It's 2.69 meters. So round at the end when at all possible. A lot of intermediate rounding, you get way, way far away from your number. Make sense? Not make sense. No, yes, thank you, one person. Okay. Pyramids. Pyramids, there they go. This is more like an oblique pyramid. This is a regular pyramid. Oblique means it's kind of like a wind blew it over a little bit. It's kind of a tilty one. Where for surface area, we're just going to work with these regular ones, which means the point on top, the vertex, is directly over the middle of the base. So that's what we're working on for surface area. We have this new idea of lateral height. It's also called a slant height. It's the height of a triangle face. So pyramids are made up of triangle faces. Your base can be any polygon, but these are triangles around it. And if you look at the altitude of one of those triangles, we call that the lateral height. The height of the pyramid itself is the distance from the vertex to the base, going straight up and down. So you have two things now, height of pyramid, vertex to base, versus a slant height, which is it's slanty because your triangle is slanty. Also called the lateral height. Now I unfolded this guy for us. So here's a pyramid with a square base, or maybe it's rectangular, that I unfolded here. If it's a regular pyramid, we're going to have a square. The sides will be congruent. So if it's regular, it is a square base. So again, capital B is the area of the base, plus the lateral area, the area of these triangles. Now lateral area is 1/2. L means lateral height times the perimeter of the base. Let's think about this. So if this is L, my lateral height, all these triangles are congruent because it's regular, yeah. So my height is what we're calling L. This small b is the length of the side of the square. How many triangles do I have? 4 of them. So it's going to be 4 times 1/2 base times height. Base in this case is small b times the lateral area, 4 times. Well, I'm going to rearrange a little bit. That is 1/2 the lateral height times 4 times the base. Now, why did I arrange it that way? Because what is 4 times the base? What is that? It's the perimeter. It's the perimeter of the base. So 1/2 the lateral height times the perimeter of the base gives you your lateral area. And somebody just did this to make this stuff. It actually does make it easier, but you do have to remember it. And kind of look on here, they give it to you. They do give it to you. They don't tell you what it is, but you have to know that LA is 1/2 LP. L is the lateral height or the slant height. P is perimeter of base. So that much you do have to know. So if I want to find the surface area of this regular pyramid, this guy is on your paper, that's good. So again, you write out the formula. 1/2 LP, the lateral area, plus the area of the base. It's a regular pyramid. So now I have to try to find these things. 1/2 LP. Maybe I'll just find LP first. So what's L? Oh, they gave it to me. What's L? 6. And what's the perimeter of the base? 4 plus 4 plus 4 plus 4. 16. So LP is what? 16 times 6. Too many. What is that? 16 times 6? 96, is that right? Yeah.
So when you have a regular pyramid, is the base always square?
It could be another shape, but it's going to be a regular shape. Right? You can have triangular pyramids, you can have pentagonal pyramids, but if it's regular, then you're congruent side.
How do you know that one side is square?
Because it's a regular square on the bottom. Right? It's a regular rectangle, which is a square. So I know all the sides are, because it's only regular. Otherwise, you're right, I wouldn't know that. So what is the area of my base then? It's also 16, just so happens 4 times 4, right? It just works. So I want half of LP plus 16. 48 plus 16, 64? All right? I did it. I hope I did it right. 64 square yards? All right, and cones. Ice cream cones, yay. So again, we're only working for surface area. We're just working with a right cone, which means that your vertex is straight up and down. It's a pyramid with round edges. That's basically what a cone is. So you've got your circular base. So I know what that area is, right? Pi r squared. There's that. I do have a lateral height here. It's just kind of that measure from the vertex to a side of that circle base. That's your slant height or lateral height in a cone. This is between vertex and the base, yeah. And the height of the cone itself is the vertex to the base there. What's the formula? Right, the lateral area, the distance around the cone, times the area of the base, there's your pi r squared. I claim here that lateral area is pi times r times the slant height. Let's see. Oh, this is way too confusing. Area of this thing. We're using area of sectors. We're going to leave this one alone. We're going to leave this alone. On right faith, or if you want to look it up yourself, you may. But lateral area is pi r times the lateral height, the slant height, times pi r squared. I think that's what they give you. Oh, look here. Right? Isn't that what they give you? They don't simplify for you. I recommend doing it. Factor out the pi r, you're left with L plus r. I think that would make it a little easier. So if I'm going to try and find the lateral area and the surface area. Oh, okay, so lateral area is pi r L, and surface area is the lateral area plus, now I want the pi r squared circle base. So this is just the ice cream cone part. So let's see. Do I know R? I do know R, it's 9. Do I know L? This is the height of the cone. What's L? L is this bit right here. Yeah. Why? Yeah, we have to notice that we've got a right triangle here. So 9 and 12. If you remember your triples, if you divide by 3, if you divide by 3, this is a 3, 4, 5 triangle. Multiply that. 15, or just use Pythagorean theorem, a squared plus b squared. So L is 15. So this is going to be pi times 9 times 15. 9 times 15, that's 9 times 15. I'll figure that out. 135? All right? You guys with your calculators? 135 pi if they want the exact answer. If they don't want the exact answer, it's probably on here. What is it? 424.12? Is that what you got? All right. Okay, that's my lateral area. What's my units? Square inches. If I want the surface area, well, I'm going to take that ice cream cone surface area, and I'm going to add in pi r squared, which is what, 81 pi? times 81 pi. Hey, big number, 107.92. Is that right? Oh, that was way wrong.
No, you didn't.
I did something way wrong. I need to add and not multiply. I'm like, that's crazy. That would be a very, very big word. That look about right? 678.59 square inches. Yeah, that's better. Surface area. And that's surface area, that's it. Finding formulas. Now they can get a little crazy here. You're gonna have to really be careful, work a lot neater than you may be used to. You need to go? Wait 1 second before we go. Volume, calculus helps you find volume. What? Read formula. And they're easier, it is easier. And I think they actually make more sense, at least they do to me. Volume is the number of cubic units that fit in the interior of a solid. So you fill it with little cubes. And how many cubes do you need to fill them up? So if you have a prism, volume is, capital B, base, the area of the base, times the height. And if you think about it kind of, right, here's the area of your base, and you're going to fill them up, each of those things. Right? Think of just layers of them. So I kind of think of it that way. I never forget what a volume is. It's how many of these bases do we have. I've got each of those bases, and they just kind of layer up that way. Oblique, now we will have some oblique pyramids, prisms, but the good news is, it's the same formula, it does not affect the volume. So think about that. So if you have this thing here and the strong wind blows and moves it over, doesn't the same amount of stuff still fit in there? Yeah, so volume is not really affected by the obliqueness of it. So you do still have to remember that the height is easy to see when it's a right prism. The height is, you stand it at the edge, here, you drop the penny, there's your height. So don't try going this way, that's not height. Height is a perpendicular to the ground there. Okay? So V equals VH. So you write out your formula. Capital B meaning area of the base. So let's find capital B in this guy. This is a trapezoidal prism because my bases are trapezoids. Like I took a trapezoid and I stretched it out. And so now you have to know the area of the trapezoid, which you do know. It's the average of the bases times the small h. So this is kind of a local one. So 1/2, let's see what I got here. This one's 8, because that one's 8. 8 plus 16, right? And the height of this trapezoid is 4. That's 24, 12, 48. Is that right? Went a little fast there, is that correct? Okay. So I know that. And then height is the distance between the bases. Well, I'm just, now I've got a height of this thing. This h refers to height of prism. And they gave it to me. So I've got 48 times my height of 6, which is 288. Please tell me that's right. Okay, now my units for volume, because you fit little cubes in here, they are cubic units. So we have 288 cubic centimeters that can fit inside here. I think you kind of know this. Right? Here's some of this. Volume's easier. Now, what's going on here? Cylinders. Cylinders is the same thing. If you look at the area of the base times h, except the area of my base is a circle, so it's pi r squared times h. Pi r squared h. That's where these come from. Sometimes I think if you know where they come from, you're less likely to make a mistake, even with the formula sheet staring in your face. You know you're using the right one. So now an oblique, here it is. It's the same formula. It's the area of the base, which is pi r squared, times the height of the cylinder. Well, let's see, what do I have here? Oh, you gave me everything I need. 7 squared, right? Height of the cylinder is when you stand here and drop a penny. 10. So what is that, 490 pi? I think. And then we type that in. Type that in, 490 pi. 1539.38. Is that what you guys are getting? And again, these are cubic units, cubic centimeters. Simply, these are simplest. pyramids and cones. Pyramids and cones are analogous. They're similar, except one's round. It's like you took a cube and you carved away 2/3 of it, and now you're left with this bit. So a pyramid is 1/3 of the prism around it that would contain it. So you take the prism formula and you just take 1/3 of it. So it's BH, but I want 1/3. So 1/3 area of the base times height. A cone is the same idea. It's like you had a big giant cylinder around it, and I chipped away 2/3 of that cylinder. Only 1/3 of it is left. 1/3 pi r squared h. Same thing with oblique. The same formulas will work if it's tilty. So here's the volume of a pyramid. Volume is 1/3 BH. What's our base? Let's assume here regular. They didn't tell us, but this is regular. Let's go with that. So we are going to go around. Base is 6 times 6. 36. Well, I'm getting area. Area of the base. Capital B is area of the base, so these two sides multiply. And my height, you're giving it to me. 13. 12 times 13. What is 12 times 13? 156. Anybody else doing this? Okay, if you're leaving that, tell me because you don't have homework. Well, just a second. You're going to have to wait. Okay, you're just going to have to wait a second. Volume with this. Whoops. Okay. 1/3 pi r squared h. So 1/3 pi, 3.3 squared, and 6.8. And in the interest of time here, you guys work this out. I got 77.55. And again, cubic centimeters. So these are a lot simpler. And we're just doing U tries now. So go ahead and try a bunch of them. You guys are leaving way early. It's really not. So our clock's working now. It's 10. It's 10. What's 10? Those by the computer clock. Those by the computer clock. Yeah, it's 10 o'clock. Yeah, I know. The class doesn't end until 10:08. Right? Doesn't it? Try them. The surface area ones I think are more challenging. Please work on those now while we have a few minutes. Hand out the homework, please, Rob. Please check your answers. There's only like 100 different ways, maybe more, to kind of mess up on them. So please check them. I'm just going to roll through here and put up answers. So if you're watching the video, you can come back and kind of check. There's a lot of U-tries. We're obviously not going to finish them now. But if you want to, I'm not going to check that you did these, but they're really good practice. Just go and practice